All right, welcome. In this video, it's going to be sort of the next step in the evolution of the NullMixer investigation. And what I thought I would do is come back and just talk a little bit about creating custom IDS rules, because that is something that you may come to depend on. That is the IDS detections themselves, and of course there's value in being able to write them yourselves as well. So to kind of jump ahead, if you're not sure exactly where we're at, there is a couple of videos that preceded this. I'll make sure to get them linked in the video as well as to put them in the comment. And what we're looking at is a number of alerts using Suricata for the NullMixer PCAP. And in particular, what we observed is that the NullMixer sample itself had essentially a check-in, and this was that GET request. So you can see there is some very unique patterns here, particularly in the URL, also the fact that it is just a plain old HTTP request. Looking at this particular HTTP event, if we look at the flow, you also observe that there was no IDS rules, at least not in the emerging threats open rule set. That doesn't mean that they don't have one in ET Pro, or perhaps there's another rule set out there that has coverage. That is, there is no alert directly tied to this traffic in terms of this malicious activity. There is an alert tied to the fact that it uses the Namecheap URL forwarding. So let's say we do want to create a custom rule for this. Now, while you certainly have all of the same information here within EveBox, I do find it helpful, handy, I guess, to use Wireshark. And just, I'm going to sort of reset things here. After opening the PCAP for this analysis, simply filter on HTTP protocol, and you'll see that our suspect request here is right at the top. So we can right click, follow TCP stream, and then as you saw before, I went ahead and I moved this up towards the top. And the idea being that I'm going to have this window up here to look at the traffic and a window below to actually write the custom rule. Now, writing rules, I think for IDS is very similar in concept and in spirit to writing rules with Yara, and that we're looking for unique patterns that will identify what we want to identify. So I want to identify this NullMixer check-in. So I want to look for patterns in this traffic. Both the request and the response are fair game here to identify it. And part of it, certainly this rule writing process is identifying those patterns. Another part is testing it against other traffic to make sure there isn't false positive noise or true positive noise, but on traffic that is actually benign. Now, I'm not trying to present myself here as a rule writing expert. I certainly had opportunity in my career, very, very fortunate to get to know many of those folks that I call friends. But it's not something that I did and do on a regular basis. And so just like anything else that I've encountered in this realm of cybersecurity and malware research and reverse engineering, there's just so many different areas that you can go down, you can focus on, and you can learn. And it's just difficult to become an expert in all of them. But it also goes to highlight that there is, there's certainly a breadth of skills that you'll want to acquire. So hopefully this helps you on that journey, no matter where you're ultimately destined. Now, what looks unique here? Well, to me, things like the addinstall.php ? Key equals, the ampersand oname open and close bracket, perhaps the ampersand count equals. We don't want to get the values because those values could certainly change with each request, with each infection, with different campaigns. So we want to look for patterns that we think are going to be fairly consistent, fairly unique. Now, we've also have the added benefit, I think, in this situation where if you go back to some of those previous videos, we also inspected this. We saw parts of this traffic, these strings in the binary that we disassembled. So now we can look at those and see exactly how they're being utilized to help us with our rule writing here. Now, I'm not suggesting that you need to reverse engineer every binary to see that, but in this case, it's something that definitely helped. So seeing these patterns as essentially hard-coded strings, and then these values, as we can anticipate just by looking at them, being populated per campaign, per infection, that just helps us to maybe craft it a little bit more precisely. Now, I mentioned we could look at both the GET, the request, and the response. I'm not going to do that for this rule, but if, say, we wanted to focus in on really trying to add precision. There is a thing called flow bits, and that allows you to tie essentially two rules together to say, look for an event in one rule, and then in a different rule, if that event was set, if a Boolean flag was set, then go ahead and finally alert. But flow bits is slightly more advanced topic when it comes to rule writing, and not something that we'll have the time to get into at this particular video. So we have some potential patterns here. How do we actually write rules? Well, as I mentioned, this isn't intended to be an exhaustive introduction to writing Suricata rules, and that's something that there are entire classes on. So if you start though with the read the docs, you'll find that there is a section here, section 6, Suricata rules, and that is going to be. So that'll be the most important for helping you just understand how in particular the rule syntax works. So a lot of things to consider. The rule format is definitely the place to start. Now, and I'll touch on the basics here, but I'm certainly not going to be able to cover everything. I'll give you the 60,000, 80,000 foot view of how this rule comes together. So I do encourage you, if you're really interested in rules, writing them, or just being able to look at a rule and understand exactly what it's telling you, rule format 6.1 in the current read the docs is the place to start. Now, what about our script? Okay, well, what we can do then for custom rule writing is we have our script that is running Suricata. It is ingesting a PCAP based off of the -r argument, and then launching EveBox after that ingestion. And so this is Suricata in offline mode because it's only generating data from those PCAPs. It's not listening to a live network interface. If you add a -S and then a path to a rule file, and this can be any file, it just has to contain valid Suricata rules, then this S will tell Suricata to ignore the configuration, because right now where Suricata is understanding where to look for rules is in the suricata.yaml, its main configuration file. So uppercase S tells it to ignore that and only load the rules at this location. And this is helpful because if you noticed in the last videos, the last video that we talked directly about Suricata, if we download the the ET Open set, which is a free open source set, and if we just download it and do nothing else with it, there's 30-some thousand rules in here, give or take the time of day that you download it or the time of the month or whatever. It fluctuates just based on what's going on in terms of the ability to output rules. So there's 30,000 rules in here, give or take, just depending on when you download it. So that's a lot of rules, and Suricata has to load and parse those before it can begin processing traffic. So when we're developing a rule, we don't really need all that extra overhead. We're really just looking for and testing the rule that we're working on. Now, if we made this a lowercase s, then this would not only honor the configuration file, but then also add in this custom rule source. So perhaps you have a deployment that has custom rules and you want to use both. That would be an option. But for testing, let's just go ahead and go with a S. I'm also going to comment out EveBox because for testing, I really only need to grep from the eve.json file to see if my alert is being generated in the fashion that I expect it to. Okay, so what about that rule? Well, here is the rule file. Again, the extension is essentially irrelevant. When it's named is irrelevant. It just has to, in that script, point to this file. And you'll see I don't have any good syntax highlighting in particular. Now, there are some other projects that I hope to cover in some future videos. It's called the Suricata language server that will help with, basically linting your Suricata rule. But I want to start with, a place that most folks new to writing rules will likely start, and that is just with a text editor. Now, the rule format, again, documentation will provide a lot of good examples. You can also go to the Emerging Threats Open Rule Set. And if you just do a search for that, or I'll make sure to post this link in the video description, this is what gets downloaded, and then this is what Suricata actually parses. So if you've updated the rule set and you're using Emerging Threats Open, then you've got this already in on the system that you're doing, that your Suricata is running on. but it's also here in the browser. So if you wanted to look for content here, pretty easy to do. But there's a lot, right? So you kind of have to know what you're looking for. Okay, so back to our custom rule. Again, this will be a very, very abbreviated introduction, but it will get you all of the necessary components to start to really start doing this on your own if you're interested. The first is the action. What should this alert do? Alert, drop, reject. There's a handful of options. Alert generates the alert. It doesn't do anything else. It still allows the traffic to pass through if this were a live, listening to live traffic. We then have the protocol. So we're looking at HTTP traffic. It is then important for us to use the right protocol, HTTP. We could use TCP, but we want to use the HTTP protocol because then Suricata will only focus on HTTP traffic that it detects regardless of what port it's on. Next is HomeNet and ExternalNet. That's just the IP space and then the port. So what this is saying is and these HomeNet variables, anything that looks like a variable like this is going to be defined in your suricata.yaml file. So by default, these are all your internal IP spaces, and any port just simply means any port. The direction arrow is indicating the direction of the traffic. So Suricata will inspect from the HomeNet on any port going to the external network on any port. And again, the external net is just typically the negation of the HomeNet. Okay, once we define that, that's kind of the crux of telling Suricata about the rule. The next part is really the art of it, telling Suricata what and how to match. So there's some metadata in here, like the message. This is the content that will show up typically when you look at the alert, say, as you saw the output in our terminal session, as you saw the output in the EveBox. We then have the flow. And this is saying established to server. So essentially what we're trying to do with this keyword here is to tell Suricata what side of the communication do we want to look at. Since we are looking at an HTTP request from our internal network, our HomeNet, to the external, then we only want to look at that. So we're saying, okay, once the TCP session is established, look at the part of the connection that's to the server. So that's from our victim, from our client, from our HomeNet to the external net, right? And so that's very important to get that right, depending on what part of the conversation you want to focus and write your rule on. Okay, the next thing is these HTTP dot and then different buffers. And these are going to be protocol specific. What they are designed to do is to take content from certain protocols and basically put that in its own bucket. So the HTTP method contains just the content from the HTTP the HTTP request method. And the idea behind that is that there's better performance. Instead of Suricata having to parse through the entire HTTP request stream, it's able to look at just that data because it was already parsed out and put in that buffer. So you'll see that there are a number of these documented, and the general rule is anytime a buffer is available, definitely use it. So you prefix what you want to match with the buffer that you want to use. So we're saying, okay, HTTP method, content is get. And now is probably a good time to just move this down a little bit and bring up our Wireshark, right? So now we can start to see what we're matching on. So there's our HTTP method get request, and there is our get request. Now, as we go from there, we're looking at probably the more unique aspects of this request. So add install.php query string, so question mark key equals. And now we're changing the buffer because we're looking at the URI. And from here, just like the previous, we're just creating content matches. So we have to use this content keyword, colon, and then the value that we want to match on. Now, these can get quite a bit more complex. You can use regular expressions. You can use different offsets and adjustments. And I'm not going to use any of that for this particular rule, but there are something that you'll read about in the docs, and you'll probably see certainly in other rules. And if you continue to write rules, you'll definitely start using yourself. At this point, we just want to continue to match content in the URI buffer. So it's just a matter of adding content and then the pattern that we're looking for. And what will happen is that as long as we don't change or define a different buffer, Suricata is going to continue to match in that buffer. So that's why you see this buffer being defined here and then multiple content matches following. Now, the last one is a little bit of a different concept that I did want to point out. And one thing that you'll observe is that with a lot of scripted languages and libraries that make HTTP requests, PowerShell, for example, this actually looks like it's using a libcurl library. You notice that there is very minimal HTTP headers. And this is the opposite of what our browsers typically do. Our browsers are typically very noisy, and they have a lot of headers both on the request and the response. And so there's idea of minimal HTTP headers. In fact, there is a number of rules. If you go and kind of grep through the emerging threats open rule set, let's see, I could probably find one if I just look for minimal. Here you go. etinfo get minimal HTTP headers flow bit set. And the idea behind it is that you have HTTP headers buffer this negation. It's this: the request does not contain accept. It does not contain if dash. It does not contain refer. It does not contain user agent. It does not contain content, right? It's missing a lot of those very, very common HTTP headers, particularly that our browsers emit. And so that should and could help with trying to identify, to eliminate any false positives and say we're not matching on any traffic that actually came from a browser, because browsers and web applications really do a lot of strange things. So this is just that idea here to say, okay, if it doesn't contain at least one of those really common user agents, let's negate the refer header. That just might help strengthen our rule a little bit. Now, you'll notice I have these backslashes. That just allows us, especially when we're developing a rule, to break up the rule on multiple lines, and Suricata will still parse the file. You may have noticed that inside of the actual rule file itself, they're all on single lines, separated by arbitrary amount of spaces, typically 1. And then the remaining content here is essentially metadata. And the only one that's really important, the SID, or the signature ID, that defines each rule should have its own unique SID, and there is a convention for how to number your SIDs in the documentation. For development, I just pick something that's high. There's the revision. So this is my first attempt at this rule. So that's going to be a 1. And that's pretty much it, right? The rest of these fields we don't actually need. But I tried to look at some of the rules that have been created recently and follow the convention I saw there. Again, if you have never written a rule before, you can look for similar rules in the emerging threat open set or other resources online, and that could help provide you with a starting point. And hopefully this video also provides ideas, and it really is a starting point. Okay, now we're ready to see what happens with our rule. And as expected, it matches, right? So there's our message. There's some of the meta that we saw earlier. And here is our internal host, external host, right? So everything matched up. Now, that doesn't always happen. Oftentimes you'll find, I know I certainly do, that I'll make a syntax error. I'll forget a semicolon, or maybe I'll misuse a buffer. I'll have content mismatches, something. And let's introduce one of those errors, go back and run Suricata. And you'll see, okay, the dreaded error message, error parsing signature. It tells you the signature, but it really doesn't tell you much else about it. It just says that there was a problem parsing that particular rule. So this is one of the challenges and one of the reasons why there is that project I alluded to earlier, the Suricata language server, that I won't have time to cover in this video, but something to check out, particularly if I don't get a video in the future put out on the YouTube channel here, so that we can talk about it together. So this process gets a little bit tricky, but that's really the flow, right? You have some traffic that you're investigating, maybe Wireshark, maybe some other way that you like to view traffic. You have your custom rule file that you're iterating on and creating those rules. You have an instance of Suricata, maybe it's your own sandbox. In this case, I have it installed in Remnix, and we have that PCAP, the PCAP file that represents our traffic. Now, one thing that I would do if I were considering putting this into production is I would probably test this rule against a larger sample set. Maybe I have a large PCAP from my internal network traffic that may or may not contain this check-in, preferably not. That way, if I run this rule against that traffic, I'm not expecting any alerts. And then if I get any alerts, that means I need to figure out why there's an overlap. I need to fine-tune my rule a little bit more. Another route to go is if you want to contribute this to the emerging threats open. And that's a really cool route because not only does it allow you to give back to the community, but you'll have the team from ET actually look at the rule, provide suggestions and ways to improve it if there are some, and it goes through the exact same process that they test rules that go into the pro set with whatever rule you provided, any rule that you find here in the open set. So it'll also go through a process of testing where something might pop up, and then they would reach out to you, that team would reach out to you, let you know, and you can figure out how to fine tune it. But if you're not willing to go that route, you can't share it, you don't want to share it, there's plenty of valid reasons, then that would be something that you would want to consider. Just having that more robust opportunity to test local, just like you would with a Yara rule. Whenever I write Yara, I want to test against a large corpus of things that I know are good or things that I know it should not match on, because then if it does, I know I've got a little more fine tuning to do. Okay, so this was kind of straight to the point. Again, if you have questions on writing rules, please feel free to drop a comment, reach out to me direct via social media. Take a look at the documentations though. That's a great place to start, and getting ideas how Suricata is really working under the hood so that you can understand the rules that are being generated when you see alerts in your environment, as well as creating your own custom rules. Hope you enjoyed the video, and I look forward to seeing you all in the next one.